Welcome to the session. Greeting of the day. In today's class, we are going to talk about non-destructive testing processes. In previous session, we have talked about the destructive testing process, and in continuous with it, we have to do the non-destructive testings also. Those in the destructive testings, we have disturbed the specimen and break the specimen. But in the non-destructive testing process, we are not going to break. And without breaking, without affecting the specimen, we are going to test the defects. So non-destructive testing contains the well-test inspector should have a working knowledge of entity methods and their applications, advantages and disadvantages, because if the radiography is there, this is the most harmful one. Therefore, we should know various disadvantages of this process also. 4 basic entities are there, 4 to 5 welding processes are there, such as the visual inspections, radiographic inspections, ultrasonic inspections, and magnetic particle and dye penetrant inspection test. So visual inspection is nothing but as usual, like viewing in the 45-degree angle on the specimens at a 350 mm length, and we should identify. Just nothing we are using, no equipment we are utilizing. It is a visual, that is named as visual inspection. So visual test is oldest method, widely used in the non-destructive testing methods. A mechanical or optical aids may be necessary to perform these visual inspections. The specimen should have well illuminated and its surface is very well cleaned. For all tests, surface to be cleaned properly for this every specimens. Often visual inspections eliminates the need of the further testing and the associated costs, because if the defect is visible, then why we should go for this various radiographic tests and magnetic particle tests? Therefore, it can be avoided. First preference is given to these visual inspections. In such a way, we can able to reduce the cost for the other tests. If it is inner defect, if it is inner defect, then we can go for the other radiographic test. If it is outer surface defects, why visually it will be visible, then why there we want to do for the magnetic particle testings? No need. So the 3 types of visual inspections are direct visual inspections, remote visual inspections, and the transverse visual inspection testings are there. So direct is nothing but a seeing visually on the spot. Remote is through the camera, through the computers we can able to see. Therefore that is. So the advantage are inexpensive, highly portable. The cameras are highly portable. Immediate results we will get, minimum trainings, and the minimum part of the part preparations are needed. So what are the disadvantages we are getting? Accuracy of visual inspection depends on largely on the experience and knowledge of the inspector. If the inspector is not having experience, he will reject everything. Even a small bump, a welded cap will also consider as a defect. The cap height maximum 1.5. If it is less than 1.5, we can accept, and less than 1 we can accept the cap height. If greater than 1.5, 2.5, then we are rejecting this excess cap height. Then it should be visually rejected. But if the inspector is non-experienced, even the 2 mm cap height can be accepted, and even less than 0.5 can be rejected because of a non-experienced welding inspector. Therefore, experience are needed to analyze the visuals. The visual inspection is limited to detection of surface discontinuities only. Right? In case the defects are inside, like porosity is available inside, slag inclusions available inside the defect, inside the welded zone, not possible to find. Surface, whether the cracks are available, we can able to find. So that type of defect can be done by the visual inspections. There are some of the disadvantages of the visual inspections. Now I am dividing as a volumetric and planar inspections. So the surface cracking defects can be done by liquid penetration test. So here I am doing the surface defects. The volumetric defects are otherwise the, each technique has the disadvantage and the advantage and disadvantages. So in case the surface defects, directly surface available, visual inspection we can find. Therefore liquid penetration tests are also possible. As I told in the 5 categories in the first page, this belongs to liquid penetration test, can helpful to determine the surface defects. Then the magnetic particle inspections is useful to find the surface defects. Then which one will find the inside and the volumetric defects, inner defects. Therefore we are using the radiography and the ultrasonic. So you see here 1, 2, 3, 4 come here. Additionally visual inspections. Here also visual inspections are possible by the surface defects are done here. So after liquid penetration we should see, that is visual inspections. So first I am taking the radiographic test for our understanding. So here X-ray or gamma radiations are imposed upon the test objects. This radiation is transmitted to varying degree depend upon the density of the material through which it is traveling. We are going to pass the gamma rays or X-rays over the specimen, and as like the scanning method, X-ray method for human beings, we are taking the X-ray. The similar pattern of X-rays are done here. The specimens are kept in between and the X-rays are kept at the bottom. Rays are passed over this specimen and falls recorded on the X-ray. Thinner areas and materials of the less density shows a darker areas. Now you see, we'll go to the image. So these are the few images, X-ray electrically generated equipment and the gamma rays of the setups are you can able to see. Now you see, likewise I am source from the source. I am sending the X-rays over the specimen, and if the specimen contains the defects here, it will fall over those X-ray film. So in such a way we can able to find. How it is we can identify? I am identifying this defect in this format. So I am supplying the radiations from the top to bottom and I am having the film here at the bottom. Therefore when the thickness is large, the specimen, the radiation which is passed 100%. If the radiations are in 100%, this 100%, 80% will be absorbed by the large thickness specimen. Therefore, at remaining 20% will fall in the film. That 20% is understood as light color, grayscale. When the thickness is less, you see here the thickness is height. This is the high thickness. Therefore, it contains the white layer, grayscale. Less, only 20% is absorbed here, 20%. Now, the same rays are falling over here, this having the less thickness. Therefore, here it is falling 80% of the rays are fall over the film. That we understand as a dark zone. And here there is no specimen. Therefore, here it is falling about 100% it is falling on the film at the corner. No specimen 100%, as like we are understanding. Thickness less, more darkness. High thickness, less darkness, whiter. Therefore, now our zone is, let us consider our zone is welded here. Our welding has been done at this location. Let us consider our welding has been done at these locations. In these locations, we have now the defects. In this location, I have done the welding and I have done the welding here. Now I have a defect here. It means I have not welded. Lack of penetration is there. Lack of fusion is there. It means weld metal is not there. Positive welding process is not done. Then it is a hole. If it is a hole, this is not considered as a thickness. The rays can pass there through the hole. 100% can pass there. Therefore, when I am considering this zone belongs to weld zone. On that there is a defect. It means there is a lack of a fusion. Weld metal is not there. Therefore, rays are 100% falling over there. It is now identified through a radiography method. So it is more exposure, dark. Less exposure, white. Less exposure is nothing but a large thickness. More exposure is nothing but a less thickness. Less thickness, more exposure. Large thickness, less exposure. We can write here. So more exposure means less thickness. Here, less exposure, large thickness. So likewise, I am understanding this X-ray methods. So by which we can able to find less exposure, more exposures methodology. A part is placed between the radiation source and the piece of film. The part will stop some of the radiations. The thicker and more denser area, will stop more radiations. Thicker or more denser area will stop. Denser means if there is a tungsten inclusions or any slag inclusions are there, that is a density. It will stop more thicker and denser. It will stop more radiations. If more radiations is there, here the falling will be less. The film will be whiter. Easily we can able to find those methods. So this is the setup of a radiation source. It is applied over the all materials at a room. If it is released, it is not a pathway. It exposure to everywhere. So we are keeping the specimens, assembled the specimens, welded specimens. Here the weld is there. Here the weld is there. We have assembled the specimens, maybe welded, maybe casted any specimens to identify the crack and defects, inner defects. So we have assembled and started the X-ray radiation setups, and it will fall over the specimen. And here at the background you see a plate. This plate contains a film. These radiations are fall over the film and we are identifying. So that is how the advantage surface defects as well as internal defects are possible. Surface defects as well as internal defects. Surface also possible. Cracks and also internal defects also possible here. Information is presented pictorially. Yes, film we have the record. Visualization no records. We are just visually checking and we are identifying, verbally telling. But here we are creating the record. It is not possible to erase. If any problem occurs between the client and the industrial fabricator, the record only going to talk there. So there is a record. That is why the quality inspector has been rejected the component. Welding inspector has been rejected the inspected coupon. Likewise we understand. Suitable for any material. All materials can be checked. Can inspect accessible components intact like a full suitcases. Minimum surface preparations are required. We are not bothering about the surfaces. Smooth surface is not required. We are not bothering because the radiation source is going to fall. And those falling, whether it is how much it is received, whether it is 100, 80 or 50, the film is going to record. Whether it is inclined surface, we are not bother. We are going to bother whether it is slag inclusions, we are going to bother whether it is a tungsten inclusions, whether it is a porosity or it is a large thickness or less thickness or denser or not denser. That is only we are going to bother. So that is why surface preparations not required. Sensitive to change in the thickness and density. So at this point only we bother. Here we are not bothering. Minimum surface preparation not bothering, and thickness and density we are bothering. So this is about the disadvantage. Many safety precautions to be taken, harmful to the humans. Orientation between the incident X-rays and flaws is critical. Many hours of technicians training prior to use. So technician training we have to give. Otherwise, these radiations will fall on the humans. Not in the closed room. The radiography should be done in the concrete closed room. Otherwise, the away from the labors. More precautions to be taken in the industrial sectors. Therefore, it is a very technical training to be given how we have to use this. The film processing and viewing facilities are necessary, expensive and time consuming. Immediately by visual inspection we can tell immediately the defect is there, but this film you have to clean, processing and the next day waiting, drying, and then we can able to find the film. As like our human X-ray taking and waiting for, and then nowadays the digital is came, but it takes more time consuming. So determining the flaw depths is impossible without the additional analog exposures. Expensive initial equipment cost. The radiography equipment cost is initially it is high. So this is the next ultrasonic testing methods. So main features, surface and subsurface also can be detected. We have seen the radiography, in that also surface, subsurface. Surface I am naming this as a surface. So I am naming this as a surface. And subsurface means here this is the subsurface. This is the subsurface. This is the inner layer. Right? So this detect method use high frequency sound waves typically about 2 MHz to pass through the material. A probe is used which contains a piezoelectric crystal to transmit and receive ultrasonic pulses and display the signals on the cathode ray tube or digital displays. The actual display relates to a time taken for the ultrasonic pulses to travel, the distance of the interactive and the backs. So these are the points we should remember. The principle of respect to similar of echo sounding. A short pulse of ultrasonic is generated by applying an electric charge to the piezoelectric crystal. They are using a probe through which the piezoelectric crystal is getting passed. Therefore, the ultrasonic rays are passed over the specimens. So such things we have to. So this is the setup, the digital ultrasonic testing setup. Here the crack material of thickness is there, and we are going to find the compression probe. Here we are giving the piezoelectric probe is kept there, and ultrasonic waves are passed over the material, and is having the wire connections through which we can find the peaks, whether the pulse echo, whether it is defect is there, pulse will be less. Otherwise, this pulses will pass through up to the total through thickness. So this is the starting point of the thickness, and this is the ending point of the thickness. When the pass through starting here and here, it gives one pulse. And again, this screen represents the thickness. When it passes over the other point, another peak pulse will come. In between, if there is a defect, here one more pulse it will start. That we identify as defect. You see here in the ultrasonic welding process, as discussed earlier, here we have the screen. In this screen, we want to test the pulse ecosystems. And then this is the named as a digital ultrasonic setup through which we are going to test. In case here we have the specimen. You see here we have the specimen, and the specimen having the thickness. This is the thickness. When on the thickness, if there is an inner defect, subsurface defects are there, this pulse ecosystem will show us. So let us consider I have taken a thickness of plate. And I have taken a thickness of plate, and I am passing through a piezoelectric crystal. I am passing through the ultrasonic. So what happens when it hits the first surface? I am naming this as a first pulse. Now this is represented as a total thickness of the specimen. The x-axis I am representing as a total thickness of the specimen, and when it keep on moving here, it will keep on moves there. It will keep on moves there. And when the surface material hits in the bottom point, and again we will have one more peak. Therefore, in the middle there is no defect is found. Now I'm changing the location from here to here, and I'm passing the ultrasonic in this path. Now again, and first peak will come here. The first peak, as usual, will come at this point. Now it's ready. And now I have a defect at this point. Now when it is hitting this path, with ultrasonic hitting the path, before going to the last thickness, here we will get one more thickness. And then again it repels. Therefore, this peak we are identifying as a defect. The defect which is related to this is coming back again. So we are observing this as a defect before coming to this point. I am identifying this as a defect. So that the same thing we will see again here. You see, so likewise a curve. See here the curve is there visibly. You can see in the screen. A curve is there. So likewise we can able to scan. This is what I told you. So here I am considering this as a material thickness. So this is the material thickness, and this is the initial pulse. It means initial pulse start here, and then this is the back wall echo. Back wall means this is the front wall. I am considering this is a back wall echo. Now, in case I am moving and I am finding here again one more, at this point we have a defect. It means it shows in the material which have the defect echo. So this is the defect echo. Likewise, we can able to find. I am considering this screen as a thickness of the material. So this is the thickness of the material. So in the CRT display, we can able to find it through the piezoelectric probe. So likewise we can able to do. So see, a same similar pattern. We have the echo. One is initial echo. This one is initial echo, and this one is the back surface echo. And in the middle we have the crack. We have the crack echo, which is detecting and coming back. The same content I have marked in the red colors to identify the defects. Advantages: it is sensitive to both surface and subsurface defects. It is sensitive to surface and subsurface defects. Length up to 10 meters can be inspected, and no consumable requires less running cost, because you see, the consumable is not there. In the radiography we have used film for each test to find each single defects. We have a film we have kept over the specimen and passed the radiographic rays. There the slag inclusions, tungsten inclusions, porosities, clustered porosities, whatever available, it is falls over the film. The entire this length specimen, we have to keep the entire lengthy film, we have to keep behind the specimen. So what it creates the consumable. That film is considered as a consumable. So that consumables are not here. A probe we are using, and then we are keeping there, and a loop it is kept between for the contact between the workpiece and the probe. So very simple. No consumable requires less running cost. A probe here, lubrications we will use a little bit. Only a single side access is needed. Only one side we can. You see this specimen we are using from here. We are accessing to those spot. So single side is enough to reach the entire through thickness, to entire all thicknesses. Only single side access is needed. Yes. Minimal part preparation is required. Minimal part subsurface preparations may not be needed. It provides instantaneous results. Immediate we are seeing in the CRT screen. But in the radiography, we have to clean, dry, and then only it's possible to at least 5 hours, 8 hours of time to consume. But here in immediate, when you're keeping the probe on the specimen, we are seeing in the CRT screen. So it is very easy. Camera being a fully automated. This is a fully automated. The operator operates, and even the machine setup also we can able to do. It is non-hazardous to the operators in the radiography, that the radiations which comes out, X-rays or gamma rays, it is harmful. But here it is a non-harmfulness. Ultrasonic waves are passed there. The equipment can highly portable. A simple probe and the scan CRT display. We can go there and we can take the compact. It is portable. So the disadvantages: the surface must be accessible to transmit the ultrasound is to be there. Skill and training is more extensive, because there the radiography is also training required. To set up, to protect, safety purposes are required. Here also it is required, because if the operator does not know how the echo represents, what this echo represents, then obviously you see we can't able to find the defect. It is the immediate results. If the operator is not having skill, and I am checking here, if the defect is there and echo is showing, if he is not able to relate the echo with the skill to the defect, and he is moving to the next location, what happens? The defect is not identified. Therefore, here the skill and training is most importantly required here to this ultrasonic testing process. The materials that are rough or irregular in shape, very small, or not homogeneous, are difficult to inspect. So surface, if I want the irregular shape is there like this, the defect is here. I want passing the probe here and it reflects here, and I am identifying that there is no defect, and therefore and again I am sending it goes here and come back, there is no defect, and it's difficult to operate here, and all the positions are difficult to operate. Therefore surface irregularities not to be there, difficult surfaces, so rough surfaces are not to be there, even the rough surface will show the peaks. So that and all to be verified. The cast iron and other coarse-grained materials are difficult to inspect due to low sound transmissions. So this and all we have to consider before going for this inspections. So what are the advantages, disadvantages? As mentioned earlier, rapid results we are getting, both surface and subsurfaces possible there. In radiography, possible. But the liquid penetration test, only surface is possible. How far it is, this is the crack available in the surface, let us consider. Visual inspection I am doing, crack is visible. I am having the defect here. Through the visual inspection it is not possible to identify. Through the liquid penetration test it is not possible to identify. But through this ultrasonic, when I am pausing here, it passes through and it is reflects, and a pulse we will get. The pulse we will get, we can find. In the radiography also we will have a X-ray. Here we can able to, it will show the cracks and we can able to find what is available. So safety, it is safe, ultrasonic is safe when compared to the radiography. Capable of measuring the depth of defects, and maybe battery powered is required, and portable also. So importantly, disadvantage, training and skill. Yes, require high operator skill, both are interrelated points. Good surface finish is required. Surface finish is not, if not there irregularities or rough surface, the ultrasonic rays will go somewhere, scattering will take place. More pulses we will see, and itself difficult to identify the crack which is heading on the rough surfaces. So defect identification is difficult. So component may be contaminated. So this probe may contaminate when we are keep on going without lubricants. That is why we are using the lubricants there. So these are some of the disadvantages. So I am comparing with the radiography. So advantages with respect to we are reading the planar defects, good for thickness sections. We have seen large thickness sections, and I have a probe here. I have a probe and it is does the job. So large thickness possible. Instant results can use complex joints, automated, very portable. This point is keep on noting. No safety portal problems because the rays are not released, X-rays or gamma rays are not there. It is no safety is good, no problem. So low capital and running cost, only a CRT monitor and the probe. So capital cost itself very less, running cost or initial cost itself very less. Disadvantages, no permanent record, because even though we are seeing in the CRT screens, when we are moving from one location to another location, immediate CRT also moves the heights, and until otherwise CRT having the recording system. And even if it is recording system is there, we have to record here, we have to go to computer connect, and then we have to see all the 5 hours of videos, whatever we are doing. So it is very difficult there. So unless it does not have the, we can tell, does not have the permanent recording methods. Not suitable for very thin joints, which is very less than 8 mm. It is somehow it is difficult to do. Not good for sizing porosities. Good smooth surface profiles are needed. Not suitable for coarse grain materials also not possible. So such difficulties like castings or some difficulties are there. The remaining part of the subjects we'll see you in the next sessions. Thank you.